So we will see Fourier series today. So if we have a function f of x and if it repeat itself after some time period or some period t, then this is called periodic. So for example, if we have a function, so this is x and I have function like this and it repeats after some time period like this, so it goes on repeating. So if we have a function like this which have the time period this point and this point, the so the time period is t. So if we have this, then we can write this f of x in terms of sines and cosine. So that is a naught summation n equal to 1 to infinity an cos omega n x plus bn sine omega n x. So what this omega? So this omega represents frequency of this wave. So this wave, so 2 pi divided by this time period becomes the frequency. This time period, again this time period can be vary depending upon the application. So this can be minus pi to pi with the sorry, this can be 2 pi, so where the limit goes to minus pi to pi. So this can be 2l where the limit goes to minus l to l, where this can be simply time period t where it goes to t minus 2 divided by t plus 2 t divided by 2. So now we need to know what this an, bn and a naught. So a naught is the average. So what we have considered t. So average of this signal will be 1 by time period divided by minus t by 2 divided by t by 2t by 2 f of x dx. This gives average value. Now an will be 1 divided by, so this is 2 times of time period into same thing, t by 2 t by 2 f of x into cos omega nx. Here omega we can write 2 pi by t into n into x dx. So similarly bn will be 2 times of time period t by 2 to t by 2 f of x sine 2 pi by t is a frequency into n x into dx. So this is, so what this says, if we have a function, periodic function, we can write that periodic function in terms of summation of sine and cosine. So that is, it says, it's very simple. So now we will see. So now what we do, we take a f of x, and if the f of x is odd function or even function, how this will change. So we will see this. So f of, let's say f of x is even. So when this f of x is even, so a naught is 1 by time period. So this minus t by 2 to t by 2 f of x dx. Since this f of x is even function, so it becomes 2 divided by t minus t by 2 to t by t f of x dx, and an will be 2 times divided by time period minus t by 2 f of x is even cos 2 pi n by tx is also even function. So even function into even function will be even function. this is even, this is even, so this will also even. So even function will provide, so 4 divided by t minus t by 2 to t by 2 f of x cos 2 pi n divided by tx into dx, So what about bn? So bn will be 2 divided by t, same, minus t by 2 t by 2. F of x is even function, sine is odd function, so this sine is odd function. So what happened? So this is odd, this is even, so this will combine and this produce odd function, so therefore this will be 0. Why this will be 0? So integration of even function minus t to t dx produce 2 times of 0 to t even function. So similarly, if we have odd function in the integral, so this will give 0. So this is some result that you can check it out. If you do the integral, you will get this result always. So irrespective of the limit, if the limit is symmetric and if the function is odd or even, then you will get this result. So now we will, so this is called cosine series, because these only contain cos terms. So namely here there is one cos and this. So if you substitute it here, bn equal to 0, therefore this, if you substitute in the Fourier series here, you will get only cos terms. So therefore it is called cosine series. Similarly, so if the function f of x is odd function, so what happens in odd function? So f of x is odd, a naught will be, so minus 1 by t minus t by t, t to t by 2 to t by 2. F of x will be odd function, therefore this becomes 0. So an will be 2 times of 2 divided by time period t by 2 t by 2. F of x is odd, cos of will be even, so multiplication of odd function into even function will be odd function. So odd function of any symmetric integral is 0. So we will left with bn. Bn equal to 2 by t minus t by 2 to t by 2. F of x will be odd, so sine will be odd, so odd function into odd function, so this multiplication becomes even function. So then we can write this term as 4 divided by t 0 to t by 2 f of x sine 2 pi n x t into x dx, so bn. So this is called sine series because this only contains sine part. So if you substitute in the above Fourier series equation, we only get sine series. So now we take some example. So you have a guitar and you want to do Fourier analysis of from guitar string, so which will be like this in some deflection. So now you can so guitar string is not not a periodic function, so you want to do Fourier analysis of this. So what you can do, you have to assume this wave is periodic, and depending upon And now whether you want to write this in terms of sine series or cosine series, you need to assume the things that is in the left hand direction. So for sine series, it has to be odd, so you need to make this function odd function. So like this, so like this it will go. So something like this. I will take some simple. So this is the guitar wave string. So now this is sine wave, this is odd function. So the another way I am assuming this is for even function. So what is the time period? The time period will be, this is t and this is also t. So therefore time period will be 2t. So now we substitute this in above equation. So we will get, so now you can, what you can represent this signal, and we constructed one odd function and one even function, depending upon which one will be more realistic. So you can take that function of period 2t, then you assume this signal is repeating itself. If you take cosine series, if you want to represent this in cosine series, then even function is repeating with the period 2t. So if you want to use sine series, so that odd function is repeating with the period 2t. So depending upon the application, so which will makes more sense will be used. So now you can substitute this in above this odd for sine series and cosine series, you will get the simplified Fourier series.